What's up, scrappers, refiners, and e-waste enthusiasts? I'd like to welcome you to Scrap Daddy Shenanigans channel, where we try to get as much as we can from the trash. Today I've been messing with some silver contacts I had, and I've got about 100 grams here. 102 grams. There's a couple of them that still have brass or copper on them. So we're just going to call that 100 grams of silver contacts. And today we're going to try to refine it to pure silver. In the first step, we are going to place the contacts in a beaker and cover them with distilled water. We're going to be using dilute nitric acid to boil away all of the copper, brass, and other base metals. Normally, a dilute nitric acid boil would be 50-50 of distilled water and nitric acid. But with all of these base metals in here, this is going to be a very, very vigorous reaction to this. So instead of adding 300 milliliters, I'm only going to add about 50 to start with. Let it start reacting, and we'll add a little bit more as we need to.
This is not an instructional video. This is how I process gold recovered from electronics. Do not attempt these processes unless you have a working knowledge of the acids and the reactions being done. Proper personal protective equipment must be used.
Even with the heat being completely off, we're already starting to see a reaction of the copper dissolving into solution. So what we're going to do here is get our other stuff out of the way, add a little bit of heat, and allow this acid to work on this until everything is dissolved. This is only maybe 5 minutes in. We're getting a huge reaction here. So we'll just give it some space, keep an eye on it, make sure it doesn't start to boil up where it can boil over, and just wait for that reaction to start to die down, getting those base metals dissolved. I let it boil for about an hour and a half, and there's no more fumes coming from the base metals, although there is still a small reaction. So we've got some metals left in there. So what we're going to do now is filter it just through a standard coffee filter. If you wet your filter, make sure you are using distilled water, not tap water, as that will form the silver chloride. So let's go ahead and filter it. We're not going to pour everything from this container into the filter. We're going to keep whatever metals we have in the bottom in this bigger beaker. And after we take a look at them, we might boil them again with dilute nitric acid. So here's what's left. Those bigger pieces were not base metals. They were some type of like graphite or ceramic that the silver was plated onto. There's a couple of contacts left in here that can keep going in the acid. This piece that I thought was silver, I'm not sure now. It hasn't hardly been touched. And I think this is gold. If y'all can see that shine, I think that might be gold on there. I don't know where a gold silver contact would have came from the stuff I'm processing, but that would be a nice little bonus if it is. So what we'll do is we'll add 50 milliliters of water, 50 milliliters of nitric, and let this continue to boil until we get rid of these other little pieces here, like this one and the ones that are still bubbling in there. So we'll do that while this is filtering, and then when we're done, we'll add it to this. I think that really might be gold, guys. I don't know if y'all can see that shine on there, but it certainly looks like gold in there. That would be pretty nice. Nice little bonus gold nugget out of these silver contacts. That would be something completely unexpected, but I'll take it. While that's boiling, we'll do a quick little test here on our solution. That's from the first dilute nitric acid boil. we're gonna add a little bit of hydrochloric acid and see if we can form silver chloride in this solution. And you can see right away it turns white, which means we got pretty good amount of silver chloride in here. And we didn't even need to add hydrochloric. What was already in there already precipitated some silver chloride. We'll add a little bit more hydrochloric and see what it does. Not quite as obvious as the first solution, but still some silver chloride in there. And I don't see any red or orange yellow fumes coming from this, so I think we are completely done. So I'll just go ahead and get this solution poured off into our filter and let it continue filtering until we have all of our solution down here in this beaker. So here's all that was left in our beaker. All of our base metals are gone, meaning copper, silver, brass, whatever they were plated onto. These are all graphite or ceramic type pieces. I'm not 100% sure. And I'm not sure what this was. I thought it was silver, but must have been some kind of stainless or something that didn't react to the nitric acid. But check this guy out. There was a gold contact in there and I didn't even know. So now I've got a nice little gold foil here that came off of one of those contacts. Here is our filtered solution. It looks nice and clean. I'm gonna add it back into this larger beaker. The next step we're gonna do is form our silver chloride like we did in our initial testing. There's a couple ways to do this. You can use hydrochloric acid. We already saw what that does and how that works. Another method is to use salt water. Just regular table salt. It can be iodized or uniodized salt, doesn't matter. You just want to saturate some hot tap water with your salt. And you just pour that right in. Oh yeah, beautiful, beautiful. We'll give that a stir. We'll go ahead and add in our hydrochloric test solution. And rinse that little bit of silver chloride down in there. Most of our silver chloride has settled down. So let's add a little bit of hydrochloric acid here where we can get a good look at it and see if we're still forming any chloride. Looks pretty good. I don't see any more chlorides forming. So what we'll do is cover this up and leave it to sit overnight till tomorrow. Let everything settle out and then we'll start rinsing it off. All right, guys, so here we are the next day. Our silver chloride is settled out on the bottom. Now we're gonna start the long process of rinsing all of the acids off of this. So first thing we're gonna do is slowly and carefully pour off the solution. I'm heating up some water in my Helmo Lacey hot cup, vintage, still works great. So we'll have some hot water ready to rinse this silver chloride and get all that acid off of there. Looks pretty good, y'all. We poured off a little bit of silver chloride. I think what I'll do is cotton filter all of this when I'm done, because with every water rinse that we do, there's gonna be some silver chloride getting poured off. So our water's heating up. We'll wait till it's nearly boiling and we'll start rinsing this off. Our silver chloride looks pretty good and clean. So our next step is going to be to convert the silver chloride into silver oxide. We'll be doing that with 100% sodium hydroxide. This is lye drain cleaner, and it's $6 from Walmart. And this is what we'll be using here. We'll add just a little bit of hot water in there. Now we'll start adding in our sodium hydroxide. So you want to add sodium hydroxide until you no longer see any fluffy white chunks in there. And I think we got it all. It looks like everything has turned grayish black. I don't see any more fluffy white silver chloride in there. This next step is the craziest part in my opinion. We're just going to be adding sugar. And we're going to be adding sugar to this until it turns pitch black. We don't want to see any gray. We want it to go all the way black. This is an isothermic reaction, which means it's going to react and it's going to get really hot. It can boil, it can foam. You want to make sure your glassware can stand it. So we're going to do this carefully and quickly. Make sure we get everything done right. We're going to add sugar and stir it until we get everything turned black in there. We want it to turn totally black. That's our first spoon of sugar. We'll give it a stir. And you can see the color already changing quickly. That's good. We'll go again with some more sugar. And there we are. Now we've got metallic silver in the bottom of that beaker. We'll let it settle out and then begin rinsing all of this lye and sugar off of it. I'm going to go ahead and transfer everything over to this smaller beaker. Oh yeah, look at all that. We'll give that a minute or two to settle out, and then we'll start pouring off and rinsing with hot water. And at this point, we're just using regular tap water. It doesn't need to be distilled water anymore because we've already completed the reaction, so the tap water won't make any difference at this point. All right, let's go ahead and get started. So we're just gonna slowly and carefully pour off our liquid. And we will get some of our silver going over, but that's okay. We'll allow this rinse water to settle out for a day, and we'll be able to recover that silver as well. Right now, our focus is just getting this main portion of silver as clean as we possibly can. Our silver's looking really great. A lot more than I was expecting for sure. I think this will be our last rinse. Try to get as much of that water out of there as we can. And there's our silver. I like it. It looks great. So let's try to get it dried out. Get our silver moved over to this little baking pan. Right, I think that ought to be good. We'll sit it up here on some low heat. Start trying to evaporate all the moisture out of this. It's about as fun as watching paint dry. So I'll skip over this, but I'll come back when it's all dry and ready to go. There's our pure silver. I'm gonna get it smashed up a little bit into smaller pieces and get it all out of there and get a weight on it. So there it is, 27.5 grams of 3/9 fine pure silver from 100 grams of silver contacts. There's a tiny amount of silver residue in this pan, and there's quite a bit down here in the bottom of our rinse solution. So I'd say 100% if all we need was a half a gram to get a metric ounce, we almost got 1 ounce of silver. I'd call it 28 or even 29 grams. Now a troy ounce would be 31.1 grams. So we didn't get a troy ounce out of it, but we did pretty good. 27 grams, I'm happy with that. That might go for $20 or so after we get it melted down, depending on who's buying it. So let's go ahead and try to melt some of this down. So there it is, guys, our nice little silver bar, 15 grams. Still got some flux on there. We'll take that off with some sulfuric acid. But not bad. I'm happy with it. I changed my mind. I siphoned off our rinse liquid, and it just seems like there's a lot more silver in there. I'm wondering if we can't get it up to that 1 troy ounce. We had 27.5, so we need 4 grams of silver. I'm not sure how much that's gonna be after it's all dried out, but let's try to rinse this a couple times with boiling water, get it in a smaller beaker and repeat the same process and see how much more silver we have in here. Okay, y'all, now we know that looks can be deceiving. I got a half a gram of pure silver out of that rinse water. So we're just gonna add this in with the other that we had. And that's 12 grams plus our little bar, 27.3 grams. So instead of remelting everything, I think I'll just hold on to this and wait until I have at least 1 ounce. I need 31.1. So we'll wait on that and then we'll melt it again and have our ounce of pure fine silver. I lied. I ended up melting it all down. Here it is, looks good. Nice and clean. 26.7 grams of pure silver from 100 grams of silver contacts, which gives us roughly 25%, maybe a little more, depending on the contacts. That was all different kinds, and one of them was gold. So 25%, I'll take it. Guys, I really appreciate y'all watching the video. If y'all made it this far, Take a second to hit that subscribe button, like and share the channel. Scrap Daddy Shenanigans. I hope y'all have a great day. I hope I got y'all thinking about going out there and processing some silver contacts. Y'all go get that silver now. Have a good one.